So I saved my parts. Now I'm going to create a new product. And I will call this product, just aircraft product 1. And then I will also save this one, save, and then I will include my fuselage part here. There we go. All right, so what I will do now is a process, the manual process for instantiating. And what I need to do is that I need to first place a part. Then I need to manually change the name of the part to, let's say, wing 1. And then I need to go inside this part. Then I go to fuselage, I go to the wing geo, and then I will copy these references and then paste special. Here I would want it with link. So I place it, paste it with link. Now I have my references. What I do now is that I go to instantiate from document. I have my wing PC here. Double click. Now I have a set of references that I need to select in order to get my wing instantiated. So I'll take wing start, leading edge line, wing end, spline wing up, spline wing down, RC, plane W. There we go, and then press OK. And now we have a wing. And we may play around with the parameters here and see that it works. Yeah, and this is this angle is for the next wing basically, and then the tip cord length we can change as well. Everything seems to be working. Now, when you do a manual instantiation, a weird thing happens is that your geometrical sets go into your part body. I'm not exactly sure why this happens, but when you're working manually, it really doesn't matter because you can just like place them out later. But when we do this with code later on, they will be placed in a correct way. So don't worry about it. And now we have this wing geo. So what I want to do now in order to demonstrate how rational this technique is that I will create a new part, and then I will just change the name of the part to wing 2. And now I will go inside wing 2 and I will, oh yeah, this is something which I missed. So what I missed was that I need to also have the plane in this geometry. So what I need to do here is I need to take a plane and then select this one as a reference, and then 0 here, offset from plane, and now I have the same plane here as well. And then I need to call it the same, needs to have the same name, plane W. There we go. Now I'll save this, and then I need to redo the process. So what I did is that I just reinstantiated everything so that I have the write references in my wing power copy as well. So now I have the next wing part ready. I will copy the references from this wing part and then just paste them here as result with link. And then I can instantiate the same power copy again, but now on a new set of references. So we take wing start, leading edge line, wing end, spline up, spline down, RC, and plane. Then we get the next wing. And this process continues. So now I have yet another reference geometry which I can copy into a new part, and then and so on and so forth. We can just instantiate it upon instantiation. I'll just decrease this one and then change this one. So this is still very basic. I don't want to put too much details in it right now. It's better to get a good holistic overview of the product before we start detailing. So what I will do now is that to show you how this actually is put together because of the external references. If I would change the leading edge angle on this wing to, let's say, 40 degrees, then this wing would be modified. Or if I would change the wing length and then update, then it would update this part as well. Any case, it's not stranger than that, and then I can just continue creating the same, doing the same instantiation for the horizontal tail. I just need to go to the right references, paste special as a result with link, and then I do instantiate from document, wing power copy. So you see, we just created one geometry, but then we are reusing it everywhere. Wing ends, line up, down, RC, plane W. There we go. And then change the length to 3, and then tip core to 1.5. And then the last one is for the vertical tail. Forgot to name this one. Let's call it HT1. So it doesn't make sense to put in more horizontal tails. Usually the horizontal tail is not more than just one section. The same goes for the vertical tail. So, but I mean, you still can use that power copy. You just don't need to keep on adding more parts. I will just paste in the references here, and then I will do instantiate it from document, wing PC, and then we're at it again. So a big difference now is that the plane here will be for the ZX plane, this one. instead of the XY plane. So that will ensure that we will actually get the vertical tail on this direction instead of this direction. Like such, and then the trailing edge will be 2000 or something. Leading edge angle will be steeper than this. Oh yeah, the leading edge angle is actually defined in this part. There we go. All right. So this will be it for this session. Now we have created a good structure in order to start instantiating our aircraft shapes. For the next session, I will complete more of the fuselage geometry, work more on the structures. But most importantly, before we do any of that, actually what we need to do is to start working with Visual Basics. So it's the Visual Basics lecture, and then we're just going to do exactly what we did now when we instantiated manually. We're going to instantiate automatically. So I will do automatic instantiation for this wing template for the next session. The session after that, we will put in more geometries and also the structures of the aircraft, the ribs and the stringers and so on and so forth. All right, so thank you for taking your time. I hope that this session has been useful for you, and if there are any questions whatsoever, please put your comments in Teams. Have a good day. Bye.